We'll continue inshallah on class constructors. Class constructors. You need to understand how class constructors work and how we define them. As I mentioned before, that for example, a class, if I have a class, as the one we used in the lab, if we have a class called time, and for this class we have a constructor called time with three parameters: integer h, integer y, and integer h, integer minute, integer second. Okay, so this one, and we have void print. Then we have a private, three private data members. Both of them are like all of them are integers: hour, minute, second. 3. Okay, so this is the definition of the class. This is the definition of the class. We need to implement the class. We need to implement the class. What we mean by implement means to write code for all the member functions. We need to write code for all the member functions. That we call it implementation. Implementation. So to implement, for example, the constructor here, as we saw before, we say time. First and this is the name. We take it as it is. For example, here. Okay, we take it as it is. And of course, we need to implement, so we will do it this way. But what we want is to connect this constructor or this function. We need to connect the constructor with its class. We need to connect the constructor to its class. To do that, we said that we need to write the class name and then the scope resolution operator and then the function name. Why we call this function or member function? It is member function, it is a function, but it is a special function. Constructors are special functions. They are functions, they work the same way as functions, but they are special. And why or how they are special? If you can tell me. What is special about constructors?
No need call.
Before we go to the call, what about the how we write it first, the prototype?
No return value.
No return type, not value, no return type.
Its name same as name of the class.
Yes, the name should be exactly the same as the name of the class. And third,
Execute automatically.
no, before that, there is one more. There is one more. Can you help? There is one more, one attribute or one property of constructors, and it is important one.
For initialization.
Huh?
It is it's for initialization.
That's the purpose. It's purpose, yes. But another thing on how we write it. It should always be public. Always be public. If you move, look here, if you move this one and you put it in the private, for example, I put it here, no problem. If I move the print and put it in as private, no problem. Okay? But if I move this one and put it private, error. Okay? If I move the constructor and put it as private, it is an error. Constructors should always be public. Always be public. So you cannot put them in the private section. You can put them in the public section. Okay? So this is the three things, the main three things for how we define constructors. And they are used for initialization. That's their purpose. And the other ones is that they are called automatically. They are called automatically. Okay? And it means that we cannot have a function call to the constructor. You cannot. How many times it is called the constructor?
Each time when it's executed.
How many times? For each instance, only one time. For each instance, it is only one time. If you have more than one instance, each instance will be called more time. But these functions, you can call them as many times as you want for each instance. You can repeat print for the same instance, no problem. And also, you might not need to call it. If you don't call it, no problem. But constructors will always be called, and they are called by whom? Who calls the constructor? The program itself. The program, you cannot call it by yourself. You cannot call it by yourself. It is called by the program itself. Okay, it is called once. It is called by the program. You cannot call it. Okay, and well, another one. First here, let's say this complete this one. So here, the purpose of the constructor, it is to initialize the instance, the object. Its purpose is to initialize the instance. What we mean to initialize? To initialize the state. The state means the data members, the values of the data members. So we want to initialize the values of our minute and second. So here, how to get the values of our minute and second? We pass them here as H, M, and S. So what to do? You say hour equals H, minute equals M, second equal S. Okay, this is how we initialize it, or how we initialize how to write the initialization for the instance. There is a difference. There is a difference. If I have, okay, if I have, for example, here I have, let's say, a function called init time, okay? Or let's say يعني change this one. Okay, now I say here void init time. I change it to init time. Okay. Now, so I need to change this one. Init time. So what's the difference now between this one and this one? Or this one and the one that I wrote before? Does this initialize the instance? Huh? Does it initialize the instance? Yes, it initializes the instance. Okay? But what is so the difference? Why cannot we write it this way?
We can write it this way, but we need to call it by myself.
Okay, so in main, if I say here, in main, if I say here, I have time t. Can I write it this way? Can I write it this way? In main, I say write time t. I am creating an instance, which is an object. Objects, instances are objects, but we call them instance because each for instance is one, means one. Object is a general, but the type, this is object is to differentiate between the class. This is a class, this is an object. But instance means one of its type, one time instance. Can we do this? Can we do this? Will this give us errors? Will the compiler give us errors when we have something like this? What errors?
Because t, it should be initialized.
Okay.
The number of data should be initialized.
So I put, like, for example, here you say, I put, like, for example, 10, this is for the hour, 20 for the minute, 30 for the second, like this. Huh? Or what? Okay, now you see what I did? You see what I did? I changed. Is this a constructor? Is this a constructor? Huh? Is it a constructor? No, it is not a constructor. It is like a function like this one. It is just a general member function. Okay? So this is how I need here void. Yes, of course I need void because there is void there. Okay? So now there is no constructor in the class. Can I have a class with no constructor? Can I have a class with no constructor?
Yes, we can.
Yes? If I have a class with no constructor, then how the instance will be initialized? If I say that I have a class with no constructor. Of course, let's say, can I have a class with no constructor? Yes. Can I have a class with no constructor? Yes, I can. Yes, I can. Then, first, now I have no constructor. I have here no constructor. Will this program give me error? Yes, it will give me error because I cannot do this way. Okay? If I don't write the constructor, I didn't write a constructor here. If I don't write a constructor, then I need to define instances this way, just by the name of the instance, no parentheses. No parentheses. This is how it works. Okay? Now the question is, well, we know, or I said that every time the object or the instance is created, at the same time or after it reserved memory for it, the program needs to initialize the instance. Then, and initializing the instance is through what? Is done through what? Constructor. Only constructors initialize instances. So how it will initialize is when I have it this way. Actually, this one, as I mentioned, does two things. First, creates instance. Second, initializes instance. Which means, if it is initializing the instance, it means it is calling a constructor. But we don't have constructors here.
We have to call that.
Okay? Then what constructor it will call? Actually, if we don't have constructors, there is a hidden constructor like this. Or to make it clear, more clear, it is like this. Okay? This is what we call this is default constructor. Default means افتراضي, means that this is the one that will be called automatically by the program if we don't have another constructor. It will call this one. There is something hidden, but we don't see it. It is written by the compiler itself. If we don't define a constructor, it will add one for us. This is how it will add. What does this constructor do? What does this constructor do? You see? Here, the action of all functions is where? In here, in this one, here. Okay? Do we have anything here? No. So it is not doing anything. Default constructors are just empty constructors. They are empty constructors. They do nothing. But it is called, this is the way C++ works. If I don't have a constructor, if I don't write a constructor, it will automatically call or put a default constructor for me. It will put a default constructor for me. Okay? So now, and it will call this one. Even, we don't put parentheses here. We don't put parentheses here. It knows that it is like this. It is like a call to the constructor, but we don't put parentheses. So it is calling the constructor. But we say it initialize the instance to what? Nothing. It doesn't change the values of the data members. So now, this is if I don't have, for example, if I don't have this one, so it will be there. Actually, it is there. Now, what if I call here? So now, if I say here init time, and then 10, 20, 30. So this will initialize the instance. So I am doing the initialization how many times? 2 times. 1 time here, it will be done automatically. And this one will be done later. So what is the difference between this way when I change it to init time and the one that was before as a constructor? Okay. You see here, if I call, the difference is that if I put here, for example, tprint, what it will print? If I put here tprint before doing the initialization, okay, it means that it will print nothing, يعني maybe 000 or something, يعني any garbage there. Okay, so but when we had it before as here, as for example 10, 20, 30 as we had before, this will print 10, 20, 30. So this is a difference, because the initialization comes after the creation of the instance in this way. So normally we don't do it as a function, a normal function. We normally do it as a constructor. So, okay? So we normally do it as a constructor this way. So we delete this one. We had it this way. And also we delete this one. Now, when I have a constructor, now I have one constructor. What about the default constructor? Is it there or not? No, it will, after I create a constructor or add a constructor to the class, okay, the default will not be added. What if I want, for example, you see here, this constructor forces me to specify the time as hour, minute, and second. What if I want to specify, for example, the start time of this class? Do I need to specify the hour, minute, and second? The start time of this class? Do I need the 3 things? The hour, minute, and second? I need only the hour and the minute. But I cannot do this. I have to specify the second. What if I don't want, if I don't know that in the beginning, I don't know what hour, minute, and second, and I want to change it later on? It means I don't know here, whatever. So I can add here, I say time, like this. This is what we call, again, default constructor. Because why default? Now, because no arguments. But this one I added myself. This one I added myself. Okay? Now here, how to write it? I write it this way. Time, and then what is inside? Hour equals, for example, 0, minute equals 0, second equals 0. I put values for but I put them all 0, 0, 0, 0. So now if the user, which means a user means the function that is using this class, if this one is not specified, for example, like this. Now, this we have here, how many constructors? How many constructors now we have? 2. 2 constructors. But the problem is that You see the name of the function, what? What is the name of the function? Huh? Time. What's the name of this function? Can I have two functions with the same name? Can? Okay, so this is the problem. Now this one, for example, let's add something. Yani this one, I don't specify hour, minute, and second in the first one. I write another one. I specify time int h. Only I specify the hour. Okay. This one I specify int h, int m. I specify hour and minute. For example, if I want to create an instance for the start time of the class, I use this one. Okay? But now I have 4 functions with the same name. 4 functions with the same name. This is good if I can do it, sir. Because if I need only the hour, then I specify just the hour. If I want to specify hour and minute, I can specify hour and minute. If I want to specify all the 3, I can specify all the 3. It is good, yani. This is now flexible. But is it possible in C++ to do this? Actually, this is one of the important aspects of C++. It is called function overloading. It is called function overloading. Overloading. What do I mean by this one? For example, I have an employee. Okay? Or let's say like in where is the Senate, for example, if you know that place, Senate, what we call it, shop or center or whatever they call it. They do a lot of things. So the employee that is there, for example, if I take some papers and I want to copy them, I give them the papers to them. I tell them I want a copy of this one, or I give them my passport. Sometimes what they do, for this one, the employee will know. So this is one job of that employee, is to take papers and copy them, or take passport and copy them, take ID and copy it. So the one job of that employee is to copy papers. But sometimes I give a paper and I tell them, please type it for me. Okay? So they type. They type what I wrote, maybe by hand. So this is another job done by the same employee. This employee is doing 2 jobs. They have also stamps, for example. If I take a stamp and give it to that employee, I tell them, replace the ink inside, they will do. So it is 3 jobs. They can have 4 jobs, 5 jobs. The same way here. This is one employee called time. It has now 4 jobs. If I don't give anything, they know what they are doing. They just go and initialize the hour, minute, and second to 0. If I give only one here, like this one, only one parameter, so it will do it this way. Okay? It will do it this way. Oh, sorry. This should be time, like this. Okay, so this one. Now this one, I specify the hour, int h. And now since I specified the hour, I put h here, and minute and second are still 0. Okay. Now if I want to implement the third one, so I put it this one. Okay, so here I am specifying the hour and the minute. So here and if I have the three things, I put it this way. See, now I have the same constructor with 4 versions. One with no parameters, one with 1 parameter, one with 3. Okay, so this is what we call this property, or this good aspect of C++ is called function overloading. Overloading means بالعربي نحمله أكثر من طاقته, overloading تحميل أكثر, means to give more jobs, more things on the same person or the same machine or something if you have. Can we do function overloading for other functions? Can we do function overloading for other functions? Yes, any function. Any function you can do function overloading. You see what's the difference between this one and this one and this one? They differ in what? In the number of parameters. You see here the number of parameters. No problem with the name. Of course, the name should be different. It should be the same, but they should differ in the name and should differ in the number and type of parameters. Number and type of parameters. For example, here. Can I write something like this? Integer s. Let's say, okay, like this. Now I have integer h, integer x. In prototypes, in prototypes, the name of the parameter is not important. I can even remove it. Okay, I can remove it. Now, are they the same? Same. Time int. You cannot have the two functions with the same name and the same number and type of parameters. But if I change this one to char, no problem. If I change it to char, no problem. I can have two functions with the same name and one parameter, but the type of the parameter is different. Here, you see here, this one, let's say here, this one, and this one differ in the number of parameters. Okay? This one and this one, they differ on the number is the same, but the type of the parameter is different. So they are not the same. You can have functions, as many functions as you want, with the same name, but the list of parameters, the number of parameters should be different, or the type of the parameters they should be different in the number or type, or both. This is how function overloading is done. You can have with the same name. Of course, this one the name of the function and the parameters, the list of the parameters It is called signature. Signature. It's called the signature, the function signature. Function overloading, the signature should be different. The signature should be different. What about return type? No problem. It doesn't care about return type. The compiler cares about the signature. The signature is the function name and the list of parameters. The function name and the list of parameters. So this is how we do function overloading. Now the question, the important question, you see here, for example, this one, okay, I have T1 like this, okay? I have T1 like this, then I have T time T2 10. Now time T3 10, let's say for example 10 20. Time T4 10 20 30. How many instances I have now?
4.
One instance or 4? 4? How do you know they are 4? I know this is silly question, but how do you know they are 4?
In the definition, there are 4. Time T1, time T2.
Because the name of the instance is different. The name is different. Why I'm asking the question? Because I know some students might not know the difference. Why? I mean, if this is 1 or 2. We know there are 4, yes, because T1 is different than T2, it's different. Even if the call is the same, for example, if I put here, then how many instances I have now?
Same 4.
The same 4. It is not by the how many arguments I send. It is how many names, different names of the same class or whatever. So now I have 4 instances. All of them need to be initialized by the constructor. First, before I go, you know that I said before that every time an instance is created, it means it reserves a memory for it. How many bytes will be reserved for each of these 4 instances? Will the memory, the size of the memory, how many bytes, will there be the same or different?
Same.
Huh? Same or different? This is the class definition. This is the class definition here. Will they be the same or different?
Same.
They will be the same. Why? Because here I have all of them will have hour, minute, and second, and all of them, the 3 are of type integer, and each integer is 4 bytes. So each instance will have 12 bytes in memory. Each instance. And each instance will have an hour and a minute and a second. Okay. Now, the program will call the constructor. When creating the instance, it will call the constructor. How many constructors I have? How many constructors I have in the class? How many constructors? 1 constructor? 2, 3, 4, 5? 4 different constructors. 4 different, I say different constructors, not the same constructors, 4 different constructors. This one, this constructor is not the same as this constructor, is not the same as this constructor, is not the same as this constructor. So 4 different constructors. Now how the program or how the compiler will know which constructor to call for this instance T1, which constructor to call for T2 and T3 and
By the signature.
by the signature. Yes, correct. This one, T1, has no arguments. So it will go to the constructor, it will call the constructor that has no arguments or no parameters. This one has one argument. So it will call the constructor that has one parameter. This has two arguments, so it will call the other one, this one here, and the fourth it will call this one. There will not be a problem with the compiler. It will know by the signature. That's why the signature should be different. If the signature is the same, it will not know which one to call. So it needs to have the signature to be different. And it will not get confused. It will know. So you have here one argument, it will call the one with one parameter. You have two arguments, it will call one with. Okay, so let's by just for example here, if I have here float, okay, let's say put this one. I think there's no time for this one. I will explain later, because this is another issue that you need to understand. It's another issue. If the same number of arguments or parameters, but they are different in type, how will the compiler know which one to call? Of course, the answer is just by comparing the argument to this is float, but there are some other details that I will explain later on. Okay? So this is what we call function overloading. And you can do it with constructors or with any function. And the function doesn't need to be part of the class. Even other functions, if I have a different function outside, except main. Main, you cannot repeat it. Main, you cannot repeat it. Any other function, you can repeat. So overloading applies to any function except main. Okay? And later on, we will talk about something called operator overloading. Not function overloading. Not function overloading. Operator overloading. And what we mean by operators means like plus, minus, parentheses, brackets, and all these. How to overload, we'll explain later on. Actually, when you say, for example, 5 plus 5, it is different from you say 5.1 plus 5. This is integer, this is integer, this is float, this is integer. So it is different. This is what we call overloading, operator overloading, but we'll see how we can create our own operators and overload them. Okay? Any question? For the assignment, I told before that it is due today. This is the first part of the second assignment. The second part, you need only just to convert the structures to classes. You don't need to write other. If you want to write constructors for them and other functions, you can do it, but it is not required. The third part, you will do that in the third part. The second part will do next Sunday. Also for the quiz, it will be in the lab on Wednesday. It will be in the lab on Wednesday. And what I will do, it is simple. I will ask you to write a structure. Then I'll tell you to write a function, for example, to initialize this structure, or to print the content of members of the structure, something like that. Okay, so and maybe in main I'll tell you, like, write in main how to create an object of this structure and how to call the function. So maybe three things. The fourth thing is that maybe I'll tell you create a class that has these functions and this data member. This member function, this just the class here, the definition, not the code here, not the code. I'll not ask you to write the code. I'll ask you maybe to write, for example, something like this, and it will not be with function overloading. It will be just a simple class, maybe with a constructor, but if I ask you for a constructor, it will be just one constructor, not many constructors, just one constructor.
It should be definition for the constructor.
I'll tell you, write a class, define a class that has these data members. I'll tell you about the data members, and also it will have, or you can, it will have these member functions, and also a constructor to initialize the instance to these values. For example, I'll tell you, write also a constructor to initialize this class, instances of this class, to specific hour, minute, and second. So it means this one. If I say to specific hour, minute, second, you should write it like this way. If I'll tell you to a specific hour and minute, you should write it this way. Just one constructor, but I'll tell you what to do. Okay, any question? No definitions. Because for me, I don't ask students to memorize. For me, memorization is not important. You need to understand, and definitions and explanation of things, but it will come by understanding, not by memorization. I don't ask you to memorize things. Okay. No other question? Okay, so done for today, inshallah.